Let's look at the differential equations. X times y prime plus y equals x times y all to the 3/4 power. Our initial conditions in this equation are x is greater than 0 and our y, when we plug in 1 for x, is equal to 16. So now the first thing I'm going to do in this situation is we first know that it is first order, and we can see that it's not linear because we see that y is to the 3/4 power. Now, if we can make this equation look a little bit differently using Bernoulli's method, we can turn it into a linear first order differential equation, and we know how to solve that using integrating factor. So let's first start by distributing that power of 3/4 to both of those x and y. Alright, from there we know that we need our y prime to be isolated and only x is on the right side. So I'm going to divide by x for all the terms. I'm left with negative 1/4 y to the 3/4 on the right. And then my next step is I'm going to divide by that y to the 3/4 to all the terms. So I'm going to be left with y to the negative 3/4 y prime plus 1 over x y to the 1/4 equals x to the negative 1/4. Now, the last thing I need to do to this middle term right here is to multiply times that n minus 1 power and also divide so that it feels like I'm multiplying by 1, so I'm not changing the equation. So I have y to the negative 3/4 y prime plus 1 over x times 1 over 4 times y to the 1 over 4 divided by 1 over 4 equals x to the negative 1/4. Now from here, this is going to turn into my u prime. I'm left with this is my u. This is my p of x, that 1 over 4x. And my q of x is that x to the negative 1/4. Alright, so by doing this transformation, I've turned my beginning differential equation into a linear first order differential equation. And now we know how to solve this by using integrating factors. Alright, so my p of x, like I said, is equal to 1 over 4x. And my q of x is equal to x to the negative 1/4. So I need to take the integral of my p of x, which is the integral of 1 over 4x, which is 1/4 ln x. Now with this, I need to do e to the integral p of x. When I do that, I have e to the 1/4 ln x, which leaves me with x to the 1/4 when I simplify that ln and e. Now, whenever I have my integrating factor, I can now multiply my u times x to the 1/4, which is my integrating factor found here, all to the derivative. I'm going to take the integral of it. I'm also going to set it equal to the integral of my q of x times my integrating factor, which is x to the 1/4 all over x to the 1/4 dx. Now when I do this integral, I'm left with u x to the 1/4 equals the integral of 1 dx. So I'm left with u x to the 1/4 equals, my integral of 1 is x, plus c. Now yes, I found the integral of this, however, I am still in terms of u, and I need to get back to my y's. Now my y that I substituted u in for is y to the 1/4 all over 1/4. So I'm going to plug that back in for y, or for u. So u is y to the 1/4 all over 1/4 times x to the 1/4 equals x plus c. Now, if I did not have an initial value problem, then I would be done. That would be my answer. However, they gave me a condition of y when I plug in 1 for x is 16. So we need to plug in 16 for y. So 16 to the 1/4 all over 1 divided by 4 times 1 to the 1/4 equals 1 plus c. Now this simplifies to 2 over 1 divided by 4, which turns into 8, times 1 equals 1 plus c. So when I subtract that 1 over, I get 7 to equal c. Now I need to plug that back into that equation so that I don't have an arbitrary constant. Y is to the 1/4 all divided by 1 divided by 4 times x to the 1/4 equals x plus, and I'm plugging in 7 for c, so I get 7. And that is my solution to this differential equation using Bernoulli's method.